Okay, let's get into the MyStatLab examples. So, first, let's look at number 5, which says a study shows that 26% of all firms in County A are owned by women. You're phoning local businesses, assuming that the national percentage in your area is true. And you have 3 firms that you call. What's the probability that all 3 are owned by women? So the fact that you're calling 3 firms, that gives you your number of trials or your sample size, whichever you want to think about it. You have your probability of success on here, and then the probability I'm interested in is that the number of successes I see, or x, is exactly 3. So let's go up and create our graph. So let's go to probability distribution plot, probability view. Since I'm looking for an equal to, we're going to end up doing that weird between must be equal thing again. So I'm putting in my number of trials and my number of successes, and then for my shaded area, I'm looking for exactly 3, so I got to do that middle, which is fun thing. And there it is. Kind of small. That's not too unexpected, because if you think about the mean here, the expected value when you do your sample size number of trials times your probability, about a third of the time, roughly. Yeah, because it's going to 0.33 out of 3. You should get close to 1. So notice 1 is the highest lump you see. Makes sense. 2 is smaller. 0 is more likely. And there you go. So kind of makes sense. Alrighty, let's move on to some other questions. So you've just launched a website and your company sells nutritional products online. And you're going to have Y be the number of minutes a customer spends during their visit to their website. Complete our parts A, B below. So when you look at this, it's not really very discrete because you could spend any number of minutes on a website. So like look at me right now, look at my recorder. I have been recording for 1 minute, 2 minutes and 1 second, 2 seconds, 3 seconds. Just kidding, I'm not going to keep doing that. Um, So any number greater than 0, which means is an infinite number of possibilities here. And more so than that, you can't count how many there are. Those are the 2 things you should look for if you're trying to look for discrete or continuous. So continuous items are ones where it's a full range of values and you can't count how many values are in that range. Okay, so let's say we were talking about a classroom. Which the typical classrooms at Northwood hold about 35 students. I could have any number of students in that classroom, but according to the fire marshal, I must not exceed 35, and I can count exactly how many are in that classroom. So there isn't an infinite number of possibilities, and I can count all of them. However, if I asked you something like to measure the amount of water intake you have throughout a given day, you should say, oh, well, I can only do so much before I would die. So probably not a gallon of water because that would give you hydro you can die from drinking too much water. I think it's called hydrophilia. I'm making up words. It's fine. The point is there's an upper limit and obviously you could drink 0. So there's this range of values you have. It's not infinite, but the number of values in between that you could drink is quite infinite. If you measure down to like milliliters and million parts of milliliters and all kinds of tiny, tiny values, there's an infinite range of things you could take on. That would be very continuous. So when I look at this, I see, oh, any number greater than 0, and quite clearly there's an infinite number of minutes that a person could take on, even though they probably aren't going to stay on it for forever. So I would say that this is continuous instead of discrete. And since it's continuous, a binomial model doesn't make sense for it, since binomials are very discrete in nature. Okay, to determine whether a random variable is discrete or continuous. The number of points scored during a basketball game. Since you can't score a part of a point, this is very clearly not a range of values with an infinite number of values in between. So we can count how many points are scored. This is definitely going to be discrete. Okay, on to part B. So the square footage in a house. Houses have a huge range of values they could take on. However, there's only so big a house can get. So you know that it's a certain number of values. It's not 0 and it's probably not 400 million billion because that would cover the entire Earth. Or not, I don't know. You can't build a house that big is the point. So there's some upper limit as to how big this could be. However, it could take on any number in between there in that range. And since it could be any minute number of 0.00 point parts of feet, especially if you're trying to sell your house, you want to use as exact measurements as you can. This is not discrete because you can't physically count it. It's not 1, 2, 3. This is very much continuous. I remember my way to spell continuous is like I say it in my head, continuous. whatever. Okay, the time required to download a file from the internet. This could literally be anything depending on your internet connection speed. And since it could take on any time in between a certain limit, of upper limit of finite number of times, it's got an infinite number of possibilities for the time unit that it could take on. I would call this continuous. The weight of a T-Rex bone. Now you might be thinking, oh, if I do this in pounds and round it up, that looks very discrete. And you'd be right, it would be very discrete. However, in the scientific community, we don't like to round. We want to be exact as possible. And so more than likely this would be a measure that is, any number of on a continuum and therefore very infinite looking and definitely continuous. Weight and heights in general are treated as continuous because there is an infinite number of possibilities of values they could take on. Okay, the exact time it takes to evaluate 27 plus 72. Now, I know you're thinking about yourself and how quickly you could do this, but maybe try to think about like somebody who's in grade school and they might take longer, or someone who doesn't see so well, or someone who, just really doesn't want to do this in their head, so they spend 20 minutes finding their calculator, which is kind of funny because I do that constantly. There's you understand that there's probably an upper limit as to how long this could take. A typical value of this is probably going to be like a minute, maybe, probably 30 seconds. But for the average person, it might take longer depending on which person you are speaking about. Maybe it's somebody who's just learning about this, in which case this is a harder problem and they might take longer. But there's a lot of different values this could take on. And since it says exact time, it could be anything. Any number of values in between what you might consider reasonable. So I'm going to call this continuous. Work on your spelling. Okay. Talking in a room all by myself. Kind of a little weird. Let's do this problem. Okay. So, this is a little bit of a problem with expected value. I wanted to show you how to do this on Minitab, in case you wanted to know. Let me get this ready real quick. Hold on. I'm going to pause it for a minute. Okay, sorry about that. I wanted to clear off all my graphs to make this a little bit easier to see. Now, the calculation I gave you in the work here is, it's great and everything, but, you probably don't necessarily want to do this by hand every time. So I'm going to show you how to do this on Minitab. So the first thing we need to do is actually enter in our data. So 0, 1, 2, 3, 4, 5. Don't ask why, that cat songs. Okay, 0.0845, 0.27, 0.3452, 0.2207, and then 0.0706, and then 0.0090. Okay, the first thing I do when I do this is I make sure I double check my values. So real quick, we're going to eyeball this, make sure everything looking good. So awesome. All right, so the next column I'm going to need is x times the probability of x, which is what I was doing in here when you multiply these two. So x times probability, 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 x times probability. And then what I make Minitab do is sum this once I'm done. All right. So we're going to go to calculate and then calculator. And I want to store my results in x times p of x. So that's what I'm doing here. And the expression I want is x times p of x. Makes sense, right? So the expression here is telling Minitab what to calculate and then where to store it. So we're going to hit OK. And notice it gives me all these values. Oh, darn. So then the next thing I need to do is I need to calculate the sum. So I'm going to go back to stats, calculator. And then what I want to do is I don't want to store this in a column. I just want to do it. I'm going to do the sum, which if you want, you can find sum in here. RS. So many R's. Where are they? Sum. And then I got to put what I want in there. I want to sum p of x. And hit OK. Too few terms. Oh, I got to tell where to store it. I forgot to do that. Sorry. Let's put it in, I don't know, C9 for fun. There's my sum. Okay, and then I would need to round this to one decimal place, so 1.9 would be my answer. Ta-da! Ooh, wow, that was a bad decision. Let's just go ahead and undo that. Okay, so next to do the variance, I need to take the difference from the mean for all of my x values and then square it and then multiply by our probability. So the first thing I'm going to do is I'm going to do x minus the expected value of x, and then I'm going to square it. So I'm sort of labeling what this is. You could do this in 2 steps, do the subtraction and then square, but I'm going to do it all in one because I'm brave. And then I'm going to multiply by p of x in here. Okay, so I'm going to create my calculate column, calculator. I want to store my results in C5, and I want to do my x column. So I need my parenthesis x minus the expected value of x, which I just got, 1.9, and then I'm going to square it. So if you're following along, I'm doing this step only, and then I'm going to multiply by my probabilities. So we'll hit OK, and that'll create that column. And then I'm going to do, what do I want to call this? Let's just call this C5 times P of x, because that's what it actually is. It's times the probability of x. So what you're doing here is you're figuring out how far away your x is from the mean, so how far each of my values is from the mean, and then squaring it because it makes all these be positive. The reason why you want to do that is because if they're negative, well, then I'm going to lose some information when my negatives and positives gets added together when I do my sum. So you're forcing positivity to make sure everything's magnitude, its size, gets accounted for. And then after you multiply by the probability, you add them all up, so you've accounted for everything in size, and then you square root to take back down that factor of I squared it, because squaring makes everything seem larger than it actually is. So I'm going to calculate. I'm going to make this new column. So my new column is C5 times P of x, and then I'm actually going to do that. I want to do, C5 times the P of x column, which is C2. We're going to hit OK. So then I want to next sum this this column, and then take the square root of that. So calculate, calculator. I want to, where's their root function? Square root, the sum of my column number 6. I need another parenthesis, and it should do all of this, and I'm going to store it in, I don't know, C10 because I haven't used that one yet. And it should do all of this in one step, at least I'm hoping so. I've had it yell at me before when I've tried to do some stuff all at once. So we might have to sum this first and then square it, but hopefully it works. Woohoo! So there's my standard deviation. Of course, we've been asked to round this to 1 decimal place, so I'd round this to 1.1. Good times. Okay. Come on, number 9. Okay, sorry. In a certain state, about 75% of drivers who are arrested for driving while intoxicated, aka a DUI, are convicted. Complete parts A through C below. Yay, facts, and then things. I always love how my stat lab reads these things. It's like reading radio instructions. Okay, if 12 independently selected drivers are arrested for a DUI, how many would you expect to be convicted? So remember, expected value, you should be thinking mean, average, or what we like to call the typical value you expect to see, hence the name expected value. So, and that would be how likely it is to happen times, sorry, I'm losing my voice a little, times the number of trials I'm going to go through. And why does this make sense? Well, if you think about it, it's like how likely I am to be successful times the number of times I'm going to try to be successful. So it kind of makes sense that it's just multiplying those two together. And so that's 9. So then they're asked, what's the probability that you actually achieve the mean? So in order to do that, I'm going to need Minitab's help. So we're going to go to graph, probability distribution plot, and choose view probability. Again, I'm doing an equal to, so I'm going to end up using a middle. I got to change my number of trials to 12 and my success to the much higher 75%. I'm going to change my shaded area to middle. Oh, it's already there, and I want exactly equal to 9. So I'm finding the probability of the mean. There we go. Ooh. And it's 0.2581. Now let's find the probability that I'm smaller than 9. So that would be this bar and all these bars. So we should expect if I do this right, this next one, I should have red on all of these. Good times. Let's go to probability distribution plot, view probability. All my setup is the same here, except for now instead of middle, I want just one tail, and that tail is to the left because I want to look less than 9. Oh, look, that value's already in there. I don't got to change anything. That's good. Let's hit OK. And yep, there's all my colors. Woohoo! Notice this is just a little bit bigger than half the distribution, which is what we about expect because the mean, it's a, well, we expect the median to split it directly in half, but this tells you that your mean is slightly bigger than the median. The other thing is with the binomial, since you're discrete and you can't be half values, it makes it more difficult to take on a different mean and median. All right, that is all I will be doing today. Hope you enjoyed.